A simple procedure utilizing thin layer chromatography can be employed to provide a quantitative determination of triglyceride adulteration of jojoba oil. All the tools necessary to conduct the analysis are included in this kit, which includes solvent vials, a solvent chamber, a vial of iodine crystals, an iodine chamber, microliter pipettes and a capillary suction bulb, thin layer chromatography, otherwise known as TLC plates, a wooden stick, 2 vials of toluene, disposable transfer pipettes, empty vials, 1 vial of pure jojoba oil, 1 vial of jojoba oil with 1% triglycerides added, which will be used as a standard, 1 vial of jojoba oil with 5% triglycerides added, which will show contaminated jojoba oil, which is out of specification. First, remove the packaging and the tape which is on the vials. This step is not shown. Remove the TLC plates. Take a single TLC plate and use a stick to draw a line onto the silica gel surface of the TLC plate. The line should be parallel to the end of the plate and be about 2 to 3 millimeters from either end. The exact location of the line is not crucial since it simply works as a solvent barrier. Next, we will prepare the samples which will go onto the plate. First, we will prepare the standard. Take a clean and empty vial and label it standard sample. Use a clean transfer pipette and place 1 drop of the standard into the vial marked standard sample. Then take a clean transfer pipette and add 3 drops of toluene into the same vial. Cap it and gently agitate to mix. Repeat this step for each of the samples to be tested, which in this case include all of your samples of jojoba in question, in addition to the 5% triglyceride sample. Next, we will deposit 1 drop of each sample onto the TLC plate. Begin with the standard. Pull out a 1 microliter capillary pipette and place it in the suction bulb. Tilt the sample vial so that the end of the capillary dips into the liquid phase of the sample to be plated. Capillary action will fill the pipette. We will load the samples onto the end of the plate furthest away from the solvent barrier. Hold the plate steady and place a sample about 1 centimeter from the bottom of the plate. Touch the end of the pipette to the TLC plate. Place a finger over the hole at the top of the bulb and gently squeeze. The sample will be dispensed onto the TLC plate. Using a new microliter pipette in the suction bulb, repeat this step for each of the other samples to be plated. Place the samples about 1 centimeter apart horizontally. The plate will hold a maximum of 4 samples. After loading all samples, including the 5% triglyceride sample, let the TLC plate dry for about a minute. While the TLC plate is drying, prepare the solvent chamber. Open the solvent chamber and add the solvent from the solvent vial, which is composed of 95% hexane and 5% ethyl acetate, both of which are commonly available from chemical supply houses. Place the end of the TLC plate containing the samples into the solvent in the bottom of the solvent chamber. Lean the TLC plate against the wall of the solvent chamber and close the lid. The solvent chamber should be on a flat surface to allow even distribution of the solvent as it wicks up the TLC plate by capillary action. The solvent should not slosh around once the TLC plate is placed into the chamber. Once the solvent has moved up to or near the barrier line, take the plate out of the chamber and let it dry for about 10 minutes. Close the solvent chamber to prevent loss of the solvent. While the TLC plate is drying, prepare the iodine chamber. Open the iodine chamber and pour in the iodine crystals. Close the chamber and wait for the TLC plate to dry. Once the TLC plate is dry, open the chamber and place the TLC plate into the chamber. Close the lid and allow the TLC plate to develop for about 15 minutes. The plate should look like this. The two most important spots to read on the TLC plate are the top spots, which are the jojoba wax esters, and the ones which are second from the top, the triglycerides. The wax esters spot is important for identifying jojoba, since jojoba is the only plant which generates liquid wax esters in its seeds. The spot located second from the top is the triglyceride spot. The intensity of this spot identifies possible contamination. In this shot, the standard, which contains 1% triglycerides, is on the left. The pure jojoba sample is in the middle, and the 5% triglyceride sample is on the right. Jojoba oil would be expected to have between 0.5% and 2% natural triglyceride content. The triglyceride spot in the pure jojoba sample is lighter than the standard containing 1% triglycerides and is therefore in spec. However, the sample which contains 5% triglycerides has a triglyceride spot which is much darker than either the standard or the jojoba sample.